Okay, let's start here. We've got a list of Pokemon, and this is a subset of all of the Pokemon, hundreds of Pokemon in the real Pokemon universe. But I started with a simplified version to see if I could solve it. And then for each Pokemon, their raw score. So how strong is this Pokemon sort of with its base strength. And then for each Pokemon, what types is that Pokemon? So Bulbasaur is, let's say, water and fire. So we have two rows in this table for Bulbasaur. And then we have for each type, so if you're an air type Pokemon and you're being attacked by water, then your weakness against that is 0.25. And lower numbers mean you're less weak, higher numbers mean you're more weak. Okay, and so this is the sort of the basic inputs into our problem here. And what this leads to ultimately is this. This is sort of the other end of things when I'm done with it. And so right now, if I weight the weakness of my team, sort of that shared kryptonite weakness of my team, if I rate that by a factor of 10, multiply it by a factor of 10, then I end up with an optimal 3 Pokemon team of Pikachu, Pidgeot, and Ivysaur. Okay, and with a total team rating of 264. So that's a blend between their combined raw scores and sort of a 10x weighting of their shared weakness. Now, if I switch to 20, you see I get a different team: Venusaur, Rattata, and Pidgeot. So Pidgeot's sort of in the mix either way. 257. You'll notice that of course I use the Fight Club font for the names of the Pokemon. If I go to 50 weight, you'll notice there's no change. The score goes down, but the same 3 Pokemon are sort of optimal. So there's no difference between 20 and 50 weight in that regard. But if I continue to crank up how much I want to sort of kryptonite proof my team, if I go to 75, I get another change. And if I go to 100, I get another change. So anyway, so this is sort of the what comes out. So let's take a look at really briefly how this was built. Okay, here's a pivot table that is looking at individual teams, possible combinations, and determining sort of how good those teams would be based on the criteria we've talked about. So over here, you'll see that we've got 3 columns. Like this first row is the same Pokemon occupying all 3 spots in our team, which is actually not legal. You can't just have the same guy over and over again. You have to have 3 unique ones. But you'll see here that if I select this whole column, this whole first column, we get 2197 rows, which is 13 times 13 times 13. And because we have 13 Pokemon types in our model. So this is every possible three Pokemon team per row. And you'll notice that our output column over here doesn't have numbers for this first batch of rows, and that's because there's duplication in these, and our formulas catch that and say, no, you can't do that. That's illegal. So I can go scrolling through here, looking at this conditional formatted column, looking for something that sticks out, and I can go for a long time. There's a lot of rows in this pivot table. I think I put a column over here that allows me to sort of shoot to one of the good teams. So here's one of the good teams. But I don't want to have to eyeball this. I want to just be able to harvest, in one row. I want a 1-row report, essentially, that tells me what the best team is. I don't want to know and be scanning myself. So let's take a look at this. We've got these 3 columns in the pivot table, and you see over here that it's the same column. It looks like multiple times, but in reality, it's actually different tables. So if we come over here into the model, you'll see that this is Pokemon 1, and it's just a list of all the Pokemon again. Remember, we had that in our Poke Master table, which is what we saw earlier, but I have a duplicate of here in Poke 1. I also have this icon column that I was going to use with Power View, but for another reason, I ended up not being able to use that. So ignore that icon column for now. I used a different mechanism for icons. So Poke 1, Poke 2, Poke 3, they're all the same table repeated. And if we look here in the diagram view, we'll see that here's our Poke Master table that we've already seen, and the different types for each Pokemon. Remember how a Pokemon can have more than one type. And then, so this 4-table pattern here in the middle, this is sort of the traditional, this is the many-to-many technique pioneered by Gerhard Bruckel, and we talked about here on the blog before. But you'll see that here we've got these Poke 1, Poke 2, Poke 3 tables, and with these inactive relationships between them. Very, very interesting. And then we also have a disconnected slicer table here, and this is what gives us the ability to weight different weakness strengths, and then attacker types. This is used elsewhere as well. If we go back to the team breakout pivot table for a second, you'll see those 3 columns. These 3 columns we're using here. Those are those 3 disconnected inactive relationship tables, and so if I want to find out the raw score of a particular Pokemon, for instance, with those inactive relationships, I have to use a calculate and the use relationship. So this use relationship activates a particular relationship. And by keeping those relationships, those 3 relationships, inactive by default, I'm not filtering the Poke Master table at all times. So, because if I filter the Poke Master table to be Beedrill from one table, Bulbasaur from another table, and Charmander from the third table, the Poke Master table would be empty. There's no rows that are all 3 of those guys. So I leave the relationships inactive and just turn them on inside formulas. It's pretty interesting, and I'm sure that I'm going to find other ways to apply this technique in the future. Max team weakness across types. This is a really interesting measure, and so it uses. Let's start here in the middle. We have a cross join of those 3 disconnected inactive relationship tables. So what that cross join does, and this is my first time using the cross join function. That cross join table is what produces the sort of like the it'll produce that 13 by 13 by 13 virtual table behind the scenes. So all combinations. It's a 3-column table with that 2197 rows. And then the filter of that cross join, basically what this does is remove all rows from the cross join table where there's duplication between the Pokemon. So it removes, now we're left with rows where all 3 columns are a different Pokemon. And then we take a top N of that based on the team weakness product score. And then take a sample, and again, this is my first time using the sample function, a sample of that top N, because if you have ties between the top sets or the top rows of the table, even top N of 1 will return more than 1, and it turns out that it'll always return 6 rows because there's 6 different permutations of the same 3 Pokemon, so they're going to have the same score. So the sample just lets me grab one of those 6 rows, because otherwise top N would be returning me more than 1 row. And then I take a max X of a cross join of the attacker types table, because I need to step through all of the different individual types that could be coming at me. I don't want to get the maximum of all weaknesses that the team has. I want to get the maximum shared weakness. And notice that it's called team weakness product. So it's actually the multiplication of each team member's weakness against a single type that determines this. This gets really, really interesting. Again, kind of like the space program, it throws off all kinds of other technology and techniques that I'm going to be using in other applications, even though I know it's hard to believe. The Pokemon thing might not be super useful in the real world by itself. I've learned quite a bit tackling this problem. Anyway, if we go to the final page here, you'll see that we have a pivot table that was hiding down here, and the titles underneath our various icons are referencing into that pivot table. And so this is just sort of another layer on top of, I can delete this team by team breakout pivot table sheet. This was just sort of a way to make sure that I was on the right track as I was building up to it. But this iterator, this rips through all those combinations and finds the top team for me without me having to go look for it. And then returns the names. So we have those, we have name text measures. We have like a calculate of a first non-blank. And you'll notice that a lot of the other parts of the measure look familiar. But then we also have here this match going on. What's that all about? Well, believe it or not, we're actually taking this name and looking over on the icon sheet and finding the matching name so that we can find the cell that contains the icon for that. Remember, I mentioned that I couldn't use the icon column. And that's because when I find the optimum team, I need to have a measure return the name of the Pokemon, and then a measure would return the icon path of the Pokemon. And PowerView doesn't support using measures as icon paths. It's only columns that you can use as icon paths. So I ended up having to find a different way to do this. And so it's called the camera tool. It's a very old feature of Excel. It's been in the product for a long time. You even have to add it to your quick access toolbar. It's in the more commands here, and it's in the aptly named commands not in the ribbon group. You got to find it in there. And what this does is it takes a picture of a particular location in your workbook and displays it elsewhere. It's very, very, very cool. And you'll notice that it has an equals icon 1. That's its reference, because you have to use what's essentially a dynamic name range to get to it. So if I go to Name Manager here, you'll see that icon 1 references it's an offset formula that's using this number 2 here to find the right cell to take a picture of and display here. And that updates every single time I make a change, so we get different icons as well. Now, unfortunately, this camera tool feature does not work on the server in SharePoint. So I think when I go to SharePoint, I'm going to have a problem. I'll have to write some sort of like apps for Office type of thing to display these icons. But hopefully in the future we'll have a different way to do that. Anyway, this is by no means a complete illustration of how the whole thing works. But I thought it was pretty cool to show off, and it would take about a 30-page blog post even just to describe what we've covered here. So hope you enjoyed it. Go to the post, download the workbook, play around with it, and also let me know if there are practical applications for this, because what we've done here is we basically developed a technique or started to develop a technique for selecting optimal sets. And what if you had like 3 different products that had you wanted to pick a set of 3 products to offer for retail that had sort of an optimal customer response, and because of basket analysis and things like that, you know that it's not just, you can't just pick the 3 products that have like the highest price or whatever. You can't use this really greedy, simple approach to determine the top 3. You have to take into account the interplay between types. So I'm sure that there are some actual practical applications of things like this out there. So write in, let me know, drop me a note, and hope you enjoyed it.